network address translation, and it's a part of my CCNA2 class. What we're using NAT for is that when we are using IP version 4, we have this well-known issue that we don't have enough IP addresses. So to preserve the IP addresses, we are using the private IP segment. And these IP addresses that are in the private IP segment are not permitted out on the internet. So we need to somehow translate our internal addresses to an external address. And this is why we use NAT. And apart from that, NAT will also give us some kind of security, because we're using some addresses on the inside our network and some other ones on the outside. So there is no obvious link between the inside and the outside apart from what we have in NAT. So you cannot get from the outside and just be on the inside with a address that you've gotten elsewhere. So the NAT will then allow us to get inside our network as well. So it's also a question of security why we are using NAT. So what we do is that we configure NAT and set it up so that the router will translate whenever we have something coming from the inside and going out to the external interfaces. And of course we need to agree and configure on what is inside and what is outside. In this case here, when we have a local area network, that's the inside. When we have something that has a connection to the internet, that's the outside address. When we have NAT, we have this terminology which defines the inside local, the inside global, and then the outside local and outside global. The inside addresses are, of course, the ones that I have on my local area network. The outside addresses, the outside local is the inside global address is my exit interface. That is the one that has the connection to the internet. Whereas the outside local and the outside global normally are the same IP. And that is, in this case here, when I want to connect to the web server on the internet, that is the IP address of that server. So my internal inside local address is the one that I've got on the inside, and typically the default gateway on the inside, and then the other interface, the one that has internet access, is defined as the inside global address. So the global is typically an address that's outside my LAN. There are different types of NAT. We have the static NAT, which is a one-to-one mapping of local and global addresses. We don't really use that because this will not preserve the IP addresses at all, because we need a one-to-one connection. Then we have something called a dynamic NAT, which translates into a pool of addresses. So I have a pool of addresses, and whenever I want them, for instance, the client's connected to the network, it will pick one of them and go to the network, internet, and go back again, and release the address, and then a new one can take them. This, of course, also requires that we have enough IP addresses to handle all the simultaneous sessions that we need. So this is actually not anything we are using. But we are using the third option, the port address translation, or PAD, which allows us to use one single IP address on the public network and translate all of our internal address into that. And we do that by using the port address to keep track of all the different translations that we have made. So this is normally what we are using when we're using NAT. So yeah, the advantages, as I said, we will preserve the IP addresses, the IP version 4 addresses on the public network. We will also be more secure. Yeah, that's really what we are using it. The disadvantages is that the performance will be degraded. We do not have the end-to-end traceability anymore, because we don't know how it's translated. Time tunneling is a bit more complicated, and initializing TCP connections can be disrupted. So some protocols need the end-to-end traceability and also need to have the initial TCP connection, and that we can have some problems with some protocols when we're using that. Yeah. How to configure it? Well, to configure static NAT, we use the IPNet inside source static command, and then we go in and set up what is the inside and what is the outside interface. And that's basically it. And then we can verify it with these show commands. The dynamic, when we want to configure that, we need to configure a pool of IP addresses that we can use to translate from. So we use the command IPNet pool and then a name and then a start and end IP address and the subnet mask. And then what we normally will do, or I think we should do it, is to have an access list to make sure that the IP addresses that we translate are real IP addresses from our internal network. So we use an access list to permit that these addresses that are coming from our internal network are translated into an external address. So we're using a standard access list. And then we bind the ACL to the pool by the IPNet inside source list command. And then again on the interface we will create an inside and an outside. And to verify it again, we use the show IPNet translation, which will show us how it's been translated, and show IP, and we can clear them and we can see them again. Yeah, so, but what we are using the most is the port address translation. And to set it up, we are again either using a pool and we are setting it up, and we are again putting in an ACL list to permit only the inside information to get here, to get through the NAT and to be translated. And again, we need to verify the inside and the outside. Normally, this is how we are doing it, because I will only have one single IP address. The one I showed you here, is when we have a pool of IP addresses on the external network. So I can have 4 static IP addresses on the internet, for instance. But normally we only have one. So in this case, we will use no pool. We will use the IPNet inside source list, blah, blah, and then we use the interface that are an exit interface, and then we use the keyword overload. Overload makes this a PAT configuration, so that whenever I have on the inside will be translated to this same IP address that I have on my outside interface. And then again, we need to configure IPNet inside and IPNet outside. Yeah, and to verify it and to see it, again, use the show IPNet translations, show IPNet statistics, and then clear, not SLEER, but clear IPNet statistics. We can also use PAT to set up port forwarding, which means that when I have, for instance, something coming from the outside, which is a web request, then I can send that automatically into the inside to a specific IP address of my web server on the internal network. And we can do it on other ports, not only web, but also on FTP or SMTP or whatever. So if I want to have, whenever there is a port 80 coming from outside, we will translate it and send it on to our internal web server. Yeah, and that are the commands here. IPNet inside source, blah, blah, and then whether it's TCP or UDP, and then what kind of a port number and what is the IP address that I want to send it to. Are we using IP version 6 for, or a NAT for IP version 6? Well, no, not really. Not the way that we are using it for version 4, because we don't really have an issue of the address space for IP version 6. But there are some other NAT things that we are using in IP version 6. For instance, when we want to tunnel information and use IP version 6 in coherence with IP version 4. Then we are using NAT to translate between IP version 4 and IP version 6 packages. NAT64. This is not a permanent solution, but when we have the transition phase, where we're using, some are using version 4, some are using version 6, then it is a good thing to have this. Yeah. So we are using NAT64 at this moment. Yeah, troubleshooting, the commands here for troubleshooting: clear first the statistics and the translation and then show them. And if you really are having problems, then you can use the debug command. Yeah, and that was it about NAT. Thank you very much.